Recording now. Okay, so you have the exam here. I really hope that you tried it because it's the only way to practice to do well in it. You know yourself with computer programs, the only way you learn how to use it is by using it yourself. You don't really learn by watching or reading, you learn by doing and using. Okay, so question 1. First thing, insert text object, so I put in the name, question 1. Now I can type. So we have 1 over 4 plus 1 over 2 over 2. That is there. And I want to calculate this, so just hit equals. And that's it. No, stop talking. Okay, question 2. Insert text object, question 2. How do we make pi? Plus E, how do I make that one? Control E. Power 3. Yes? Got that? And we wanted the 2 significant figures, so simplify, approximate for 2 digits of precision and approximate, and there you go. Is that okay? Yeah. Okay, question 3. Expand this. So we have 2x minus 1 power 4 and then x minus 1 power 3. I know it looks a bit messed up on mine, but don't worry about that. It's just how the font is displaying. Right, so there it is there. And how do I expand? It's simplify, expand, and there it is there. So far, I think we all should have 3 out of 20, right? So number 4 now, it's getting a little bit trickier. Insert text object, question 4. So we have e power x equals x minus log x plus 1. Yeah. It's ln log. Now we want to solve this. So solve expression. Make sure you pick real and you can pick either. Remember what either does? It tries its best to solve it algebraically and fail on that does it numerically.
So do we always keep it real?
Yes. Yeah. Keep it real. You know it was good. Hey, do you need to give something to someone?
Somebody.
Yeah. You're taking precious Derive time away from them. Okay, that was number 4. Okay. Number 5 now. Let's see. What are the exact roots of this? Now, Two things before I do number 5 here. This one here, I want the exact roots. What does that mean, exact roots? It means you want to solve this. So what should it equal?
X.
Yeah, but what should this number 10 line equal? Should equal 0. In Derive, if you don't make it equal to 0, then it automatically assumes you mean equal to 0. So if I was to do solve expression, it's going to assume I mean it's equal to 0 because it's no equal sign here, not equal to anything. Do you understand?
Yeah.
If you want to write equal 0, that's fine. You still get full marks. Now, just be careful. You absolutely want algebra here because you want the exact answer. Not a decimal, not anything like that. The exact answer. And you still want it to be real. Huh? Yes. Keep it real. And there are the two answers. X is -2 or X is 1. Now I'll just fix the font again. Idea, did that program work yesterday?
I downloaded it, but it kept opening as a file.
The EXE or the program?
I also downloaded the Wine program.
Yeah,
And I also downloaded the
Derive.
Derive, but I don't know how it works after that.
Might have to use the school computer then.
Yeah.
Yes?
When writing it out, instead of doing the whole print process, can you actually type out?
Yep, you sure can. Yep. You can type this in as a command as well if you like. Okay, that's number 5. Happy with that? Yes? Okay, next one now, number 6. Let's see. 2x cubed plus x squared minus 13 x plus 6. Fix the font again. Okay. Factorize. Which one's that? Simplify, factor, and well, it's only x, so factor, and there you go.
If it's X and Y, will you tell us which one you want?
Either each.
I don't think I'll do that, but if I did, I would tell you, of course. Yes. No, I won't do that. I won't do that. Okay, that's number 6. So number 7 now. Now in number 7, I want you to set the expression in 5 equal to that of 6 and solve. So number 5, there it is there, it's on line 10, and number 6 is on line 13. So on this one I was testing your knowledge of the hashtag symbol here. So it's line 10 equals line 13. Now just have a look at that and make sure you're happy with that. Do you understand why I did that? Yes? Okay.
Is that equal or what?
It's an equal here. Really? Man, wear your glasses, seriously. Okay, and I want you to solve numerically. So again, solve expression. This time I'm telling you to pick numerically because I don't think there is an answer that's exact. No, you see there's not. It's 3 decimal numbers here. If you try, well let's see, by the way, if we try to do it as, look, let's try and see what happens if we did it using either. So first algebra, then numerical. I have a feeling that it will give me an exact answer, but it'd be really, really big. No, it couldn't even do an exact answer. I did pick either, didn't I?
Yeah.
Okay, let's see what happens if I try, try to force it to do exact answer. Yeah. So that's why I tell you to do it numerically. But by the way, if you did it as algebra exact, you could go back to numerical here by just doing approximate. But anyways, we'll stick to how I said in the question. Solve expression numerically solve. Okay. So that was 6. Sorry, that was 7. Okay. Number 8 now. Sine 1 over 1 plus x. And I ask you to put x equal to 1. So sub x is 1, simplify, there's the answer. But I'd also like you to give it to me as a decimal as well, so I'll just hit the, no, not that button, the approximate button as well. So give me both here. If I don't say and you're not sure, give me both. You'll still get full marks.
So to give this a more easy.
So simplify, approximate.
This is question number 8.
It is, isn't it? Yeah. Okay, 9 now. So I give you 2 equations. Y equals 2x plus 3. 2x plus y plus 1 equals 0. Now, I don't know. Usually you have y equals mx plus c. So let's do the graph for this one first to see if it'll work. So if I click graph and graph, it's okay, good. Tile vertically to get both screens up. Okay, now we'll add this one to the graph, graph, and there you go. Yeah, that's it for this one. So I can put this one in now for number 9. So if we go back to the graph and do insert, or sorry, file, embed, there it is there. Embed.
So we're not expecting to solve anything of this.
No, that's actually the next one. So I ask you then, where do they meet? So this is solve, insert text object, question 10. Now you see, look, this is messed up. I need to drag my graph up here so it's before question 10. Oh, come on. No, I don't, because I remove this. Move up. Yeah, okay. And then insert text object. There we go. Okay, number 10 is I want you to solve, find where they meet, okay? So we just do solve system, 2 equations, and what lines? 21 and 22. And by the way, if you really wanted to, you could actually type the equations in here, but I don't see why you would do this, but it would work if you did that as well. So line 21, line 22, x and y, and solve, and there's the answer, -1 and 1. So I need to add this to the graph now. Window, tile vertically again. Okay, so to add this point to the graph, if you remember, here's the graph here. Left click, right click, insert annotation, and the point is -1 and 1. And there it is on the graph. And now we have to embed it again. File, embed.
Also, you put 2 graphs.
2 graphs should be in your file, yeah.
Do you want to repeat how that x equals -1?
Yep, I did solve system and 2 equations, and I typed in line 21 and line 22 and solved. I think it was 21 and 22, yeah. Okay, what's next now? Question, where am I now? 11. Oh. Okay. 11 here, another plot actually. So what I'm going to do is delete the other window I had open here. Start over. Wait, no. Okay. 11, I have y equals x squared plus 3x plus 1 and x plus y minus 1 equals 0. And let's draw the line first. So plot and plot. And then let's add the quadratic. Plot and plot. That's good. But I tell you something about the range here. I want the x to be from minus 7 to 1 and y to be from minus 2 to 6. So what you do is set range, minimum and maximum. Yep. So the x goes from minus 7 to 1, and I tell you don't need to change these. I think in the video I said change it to 10. All that number tells you is how many ways you break the line up. So 10, 8, whatever. You can just leave it. It's fine. And then the y, yep, is minus 2 to 6.
How do you...
Yes, question?
Where did you go to get this set range?
To get this open, yeah. I did set plot range min max. Yeah, you got that? Yeah? Okay. Now I have to include this in my file here. So file, file, embed. Sorry, click the graph, file, embed. Okay. Okay. Now on to matrices. Insert text object. Question 12. So we need to put in a matrix now. So that's author matrix. And what matrix would number 12 be? It's 2 by 2. Yep. So we have minus 2. Yep. 6, 4, minus 1. And okay. Yes? Now, the question says square it. So this would actually be line 27 power 2. Which equals, there's the answer. Yep. Yes? Okay. Insert text object. What am I on now? 13. Okay, so we have another matrix here. Author matrix 2 by 2 again. 2, 7, 3, and 8. Okay. And we want the inverse, so that's power minus 1. So that's line 30, power minus 1. There it is there. And equals, and there it is there.
Can I do it in one step?
Yeah, if you wanted to, yeah. Is that okay? Yeah. So next one now, question 14. I have 3 matrices to type in. So the first one, insert text object. Sorry, that's not what am I doing? Author matrix 2 by 2. First one is 1, 5, minus 3, and 4. Okay. And then author again, matrix, 2 rows, yeah, and 1 column, 2 and -3. And then finally another one of the same type, 4 and 7. Okay, so if we look carefully here, I want line 33 multiply line 34 plus line 35. Yeah. -9, -11. Yes.
You remember when you once told us that the order is important?
Yes. Now that's when you're multiplying 3 together. In this case, actually, if I did something like put the 35 at the back, like this, I'd still get the same answer. So the order is very, very important when you're multiplying 3 together.
If they're all multiplying each other, which order would you do?
Well, I tell you, just keep it the order that's in the question. You shouldn't have to figure out the right order. My order should be correct in the question. Who's this lost person? No, wrong classroom. Equals. Okay. Yes, that one's okay? That was 14 now, so 15. Question 15. Yeah, another matrix one here. Insert text, no, what do I keep doing? Insert matrix, author matrix, 2 by 2, 2, -2, -3, 8. And then I want the determinant here, so that's the determinant of line 38, which equals 10. I typed it, DET. See how it is here, Amjad? DET, line 38, just type it. Okay, 16 now. Let's see, another matrix one, author matrix 2 by 2, x, 2x -4, 2x, x plus 3. Yep. Now here I say, for what values of x will this not have an inverse? When determinant is or is not 0? Oh, you see, you had a 50-50 chance. If it does not have an inverse, it is because the determinant is 0. So, what line is my matrix on? It's on line 41. So, determinant of 41 equals 0. There it is there. Solve expression. Let's try either, because I don't say exact or numerical. Well, no. Let's see if we can get an exact answer first. That's always best. And we can, yeah. So solve algebraically.
So when it's not having inverse, so it's equals 0.
Yep.
And if it says we don't put equals 0?
You put not equals 0, which is this symbol. You can't, where is it? It's, there it is there.
Yeah. Okay.
So, yep.
Doesn't have to solve it.
Right, so there's the matrix. What line is it on? 41. And determinant of line 41 equals 0. There it is there. And you want to solve this expression. And we shall try to find an exact algebraic answer first. Solve expression algebra. Yep. You see, if the problem with using either is that if the algebra answer is too messy, it will skip to the numerical one. So maybe. If I tell you what, if I don't say in the question, you should always try for the algebra one first. But if it doesn't give you an algebra one, or if it looks really, really messy, then you can go for either. But I can't say you should always use either. That wouldn't be right. Mostly, but not always.
So,
Yeah.
So it's always algebraically, unless it's complex, then...
Yeah, algebra is always the best one. Sometimes algebra fails, and you have to do numerical. Yeah.
Why not fails?
It would fail because it wouldn't give you an answer. It would give you the equation again. So, like for example, if you got an answer like this, where it doesn't tell you what the x is, that's telling you that it couldn't find the exact answer. But it did give you the x, so it's fine. Is that okay? Yeah. All right. Number. What one are we on now? 17. In this one we have to define a function. So we say f of x, and to define it we don't use equals, we use this colon equals, which is actually also on the keyboard here. And then we type in the function. So if you look carefully at that symbol in the middle, there will be people that will forget about the colon and will not get that 100%. I'm always worried every year that NTUK will say, hang on, something's wrong here. All of the students got 100%, that's not right. And I'm always worried that this will happen, but it never happens. Because there's always one person who forgets one thing. So I don't have to worry about this. Okay? So forgetting the colon is a common thing to forget here. And then we want to calculate this. 1 minus f of 1 all over 1 plus f of 2. And just hit equals. There we go.
why did you make it, it says 1 plus 2x squared.
Isn't that what I typed in there?
What's the point of writing the first step?
This one here?
Yeah.
Well, if you didn't write this, it couldn't calculate this because it doesn't know what the f is.
Okay.
Yeah?
But how did you merge with question 5 and the 45 and the 46?
Yeah, good question. How does this go together? This here is set for the entire program now. So if I ever use f of x again, it will assume this until I close the program. So I could have put this on line 1 and still used on line 46. It's what's called global now. It's set everywhere in the document.
And you won't give us another question?
No, that'd be terribly cruel. If I did, I would have to call it a different letter like G or H, yes. Oh, actually, hang on.
Yeah,
There is one. Oh, yeah. That is cruel, isn't it? If you reset f again, it deletes the previous definition and goes to the new definition.
So how do you reset it?
By just making a new definition again. It sees a definition and deletes the last one, you know. So when you do this again for the later question, it ignores the previous one. Yep. Okay. That's 17. 18 now. Right, so for this one, it's 1 over n squared.
That's 19. Doing 19.
Are you sure? That's 18, isn't it? Now, I want the sum from 1 to 10. So there's a nice big summation button here. So I make sure my 1 over n squared is highlighted, pick the summation button, and it's from 1 lower limit to 10 upper limit. Sound familiar? Yeah, just like in integration. And simplify. There you go. Now please make note of the vocabulary here. I say in question 18, I want the answer exact. Exact, which means this. If I said approximately, or numerically, or roughly, then you would have it like this. But I don't. I say I want it exact, which means the fraction is what I want here. No, I could easily replace that question and say calculate that approximately, or in decimals.
When you say approximately, use the simple maths. Like,
Sometimes this doesn't actually always work, but if you go simplify approximate, that always works.
So how do I do it again? Should I go
Simplify approximate. Yes? Okay. Insert.
you use the same thing for decimal digits, right? Digits.
Digits of precision, yeah. Question 19. A limit now, so I need to type that big limit in here. So first you type in the function n squared plus n plus 1 over 2n squared minus n plus 2. And limit here is being used as a verb, meaning to make n go to infinity. So we click the lim button here for limit. And now we make n go to infinity by clicking the infinity button, which is here. And simplify. Yep. Easy peasy. Question 20 now. Huh? It's not as bad as it looks. First I define the function f. So f of x is defined to be cos of x. Secondly, I type in my fraction there. F of x plus h minus f of x. And then finally, the limit as h goes to 0. So once again, well actually before I go ahead, what am I doing here? What is this called? You did it in maths class like 1 week ago. It's derivative, and the name of this process is first principles. What should the derivative of cos be? Minus sign. Limit as h goes to 0, and you get minus sign. Yeah, but you'd be surprised how much you forget when you're sitting in front of the screen tomorrow.
Yeah. Not tomorrow.
Not for you, but yes. No, it'll still be next week, yeah. That's more time to forget.
No, I have more time to practice.
No. In reality, it's more time to forget. Because right now, this is fresh in everybody's head. Like, yeah, I saw this yesterday, yeah. No. It's a practice version. No, there's like, I have 4 or 5 different exams. They're really easy to type. They're only 20 questions.
Are there
It'll be similar to this, of course. 20 questions, 1 hour.
So this is as hard as
Yeah, like I mean, if you could do all of these 20 at home, and if you did all of these 20 at home last night and you had no problems, and you got the same answers I got this morning, then yes, I'm expecting you to get 20 out of 20 again in the next test. Yeah? Now, just before I close this program down, it's not in this practice exam, but I did do it in class. So just to remind you how to calculate a derivative. So I'll use number 20 as an example. So there's f of x. And the way to calculate a derivative is you have two choices. You can pick calculus derivative, or you can click the derivative symbol here. Both do the same thing. Calculus differentiate, and it's x. And what do you think this number here represents? If it's the first derivative or second or so on. And simplify, and you see, same answer, minus sign. And then, I won't give it to you in the exam, but just so I can show you, how do you think you do an antiderivative? Well, again, it's calculus and integrate, the symbol, or you can pick the symbol here. Yes, you remember this from yesterday? Yeah. So, for example, if I pick this, and notice how I have the limits as well. So, for example, I could do, remember definite, indefinite? Definite 0 to 1. You see? 0 to 1 minus sine x turns out to be cos 1 minus 1, which is approximately that. Now, I'll just say, wait, let me just say, do this practice test, do the 4 worksheets, and you will do fine. Okay? Also, I will give you a hard copy of the exam, but when you finish the exam, you pick File, Save As, and this is important, please. Save it on the desktop. And the name should be your student number, so you need to know your student number. So it'd be something like DB hyphen 13 hyphen 1234. How's that? Sylvia has your student number. Your NCUK student number, not your Griffith College student number. Okay, well, if you email Sylvia, I'm sure she could put it maybe on the notice board, a list of people's name and student number. Okay? I'll ask her as well too. So your student number for NCUK looks like this. It starts off with a DB, and then it's the year, which might be like 13 or 14, I don't know, depends what they use, and then it'd be 4 digits. Okay, I don't know if they'll use your graduation year or your enrollment year, so it'll be a 13 or a 14, and save that on the desktop. So you see, there it is there. And then what you do, you go to Moodle, you go to ICT page, and at the bottom of the page there'll be a little link that says upload your file here. You click it and you upload it. Just like, you know, when you attach a file to an email, it's the same process. You click browse, you pick your file, you click upload, and then it says are you sure, and you hit OK. Yes?
And this process within 1 hour exam?
Yes, and also what I'm going to say is that file, that link is not there right now if you go to look for it. That's because it's timed, meaning that it will be only available for 1 hour during the exam, and then it closes again. So if you don't upload it in time, then I'll give you 0, okay? Because you know exam times are strict. When the exam is over, you're finished, okay? So the link will appear for, what time is your ICT? 10 to 11, isn't it? It'll only be available for that 1 hour. So if you come late, doesn't matter. You just lose time. What's confusing you, Faisal? You know how exams work. If you're late, you lose time. And you have to finish when the teacher says to finish. But what's great about this is that it's 100% controlled by the computer. So when I say finished, really is finished. You got that? Yes? So again, Moodle, ICT, and the link will be at the bottom. It will say upload your exam here or something like that. Okay? Later today, I will upload the video here and this answer file. and the exam as well, if somebody didn't have it. Okay? Don't know what else you need. It's up to you now. Okay, we're finished there, so